Okay, can do a little video on how to set out a graph here. I've taken some data of Firefly for an insulation practical, and we're going to graph here the independent variable, which is time, against temperature. So essentially my graph is going to have the independent variable time on the bottom. That's the thing I've allowed to change, and temperature, which I think is going to depend on the time. So that's the result, the thing I've ended up measuring. And so we're going to plot this graph here. Now the first thing we've got to do is set out our scales. So we're going to take our axis. I'm going to have my y-axis here, and I'm going to have my x-axis along here. Ooh. Right, and now we've just got to work out our scale. So this is where you go back to your data. Now we're going to take our time axis first of all, and we're going to have a look at what we're going from and what we're going to. If we look at time, the smallest number is 0 and the biggest number is 15. So I'm going to start on 0 and I'm going to end up going to 15, but I want to do so in equal steps. So I'm going to zoom in a little bit here, and as you can see we've got one big square, and that big square has 10 little squares across there. So it gives us a scale and we can work out numbers in between, but I'm going to go for 2 for every big square. So 2, 4, 6, 8, 10, 12, 14. Now, I'm not going to write 15 here, I'm going to write 16, and that will allow us to have 15 sitting just in between on that line there. For those of us who aren't clear on graphs, just make sure that the number and the dash sits exactly on the line that you're saying. Look at, I'm going up in equal steps of 2. 0 to 2 is an equal step as well, so we're going up by the same step here. A lot of people make the mistake here and put the first number a bit closer. That first step from 0 should be the same. Okay, what we're now going to do is we're going to have a quick look at the temperature, what we're going from and what we're going to go to. I'm going from 89 and I'm ending up at 60. Now I can set a scale from 0 to 89. However, what I'll end up doing is I'll have all of my data points plotted up towards the top. So if I start at 0 there and 89 there, I'll basically just have all my data here. And what I really want to do is look at how it changes in a bit more detail. So for this one, I think it's appropriate that we're going to start at 60, which means I'm going to sit from 60 to, well, I could go up in 8 to 89, but I'd have to go up in steps of ones. So we're going to round that up to a nice round number, so 90. So I'm going to go from 60 to 90, and to do that I'm going to take I think 5 for every square. So 65, 70, 75, 80, 85, 90. And we now have our scale. So now it's going to be a case of just plotting the points. When it was 0, it was 89. So I'll go across to, first of all, really important, never forget this, write down your axis time and write down the units. That's not seconds, that's minutes. Got to be really clear so you're communicating what you've done and what you found out, and the units are part of that. Temperature in degrees Celsius. So now we're going to plot the points 0 and 89. So I'm going along to 0 and I'm going up to 89. Well, how far up is 89? Well, this is where you've got to work out what these little squares represent. I've got a jump of 5 here, and I've got, well, this will be your graph paper, you will have 10 squares for that big one, which gives us 5 divided by 10, 5, that change chopped up with the 10 squares on your graph paper, gets us 0.5 per little square, which means I'll come back 2 squares and 89 would be around here. Then we go to the next one. In 1 minute it was 89. Well, 1 would sit in between, and I've moved and wiggled my points across slightly, unfortunately. There we go. 1 would sit just there, and it was 89 again. Then we're up to 2 and 85. And so what you do is you continue down with this, 81, until we've plotted all of our points. So here are our points plotted. What we now need to do is get a line of best fit. Now, ordinarily we think of a line of best fit as a straight line that goes through most of the points. If we have a look at this top right hand corner here, I've put some random points there. If that was a line of best fit, I'd maybe be tempted to put a line straight through there with an equal amount of numbers this side and an equal amount of numbers on this side. Doesn't have to go through everything. Now, the temptation here is to go through and put a straight line. However, I think what we've seen is quite a clear curve, and you've got to be clear that sometimes it will be a curve. Now that is a bit wonky, it goes all over the place. It looks like I'm trying to line up the points. We need a smooth curve all the way through, going through as many points as possible. Okay, put a title on your graph and then move on to your conclusion.